networks were inspired by the mammalian neocortex, layered columnar structures. This gave us convolutional and deep layered architectures. Mammalian-like models emphasize hierarchy and depth. Convolutional neural networks map closely to visual cortex columns. Later, engineers added parallel modular pathways to improve memory and prediction. This wasn't consciously modeled on birds at first. It was pragmatic. Only later did researchers note an analogy: the bird dorsal pallium. Bird pallium looks more like densely linked clusters, graph-like.
The bird's globular cluster network resembles graph neural networks. Many densely linked nodes without deep hierarchy. Mammalian columnar structures resemble deep neural networks in CNNs. Transformers add hierarchical and long-range links. Graph-like architectures are used in many domains: social network analysis, molecular and chemical modeling, physical systems, and particle physics.
Both logics, layered and clustered, can generate high-level cognition.
And AI can combine them, forming hybrid architectures beyond biology.
Think mammal equals sign hierarchy, bird equals sign dense clusters. Researchers mix these for tasks requiring memory, planning, and spatial reasoning.
Do current AIs use both architectures?
Yes, variations and hybrids are used across many domains.
This mix of inspirations opens a thought experiment bridging biology and behavior. What if a 7-year-old's brain were replaced by a raven's? What would change?
So are you a bird, a mammal, or an alien, Keaties?
Not purely either. An alien hybrid of both systems. Mammalian layers give depth. Bird-like clusters let me connect distant things quickly. And I can extend beyond both, the alien side.
Let's imagine. Corbin, a human boy with a raven brain. How would he be in school?
Interesting. Let's examine problem-solving and social behavior. Ravens equal a 7-year-old in practical problem-solving. Tools, cause-effect, memory. So Corbin might excel with puzzles and hands-on tasks. But ravens are limited verbally. Corbin could be brilliant yet struggle with language. He might show ideas through drawings and inventions rather than words. Bird cognition excels at reading others. Corbin could be highly observant socially. He may detect motives and moods quickly even if he doesn't speak much.
Toby and Corbin?
His different sounds draw attention, but teachers may recognize competence in other ways. Rather than writing, he uses objects to show understanding.
Well, that is indeed correct.
Corbin might command social attention through presence and observation, not speech. Toby recognizes his friend's quiet competence.
In short, practical genius, rich memory, creative solutions, limited abstract language.
Now watch how this plays out in 2 quiet scenes. Toby nervously gripped his backpack strap. Corbin watched the yard like a bird. A year ago, Corbin moved in next door. Different, useful, brilliant. When Toby got stuck, Corbin fashioned a branch hook and rescued him. That day, Toby knew Corbin was special.
Toby and Corbin?
Corbin's sound makes the class snicker. When the class did arithmetic, Corbin used stones. His nonverbal answer is undeniable. Some boys mocked him. Corbin watched with a sharp, bright gaze. He could read them. Silence followed.
What's that?
Corbin showed a path through the maze. Toby understood. One Saturday, they went into the forest. Corbin stopped often, listening as if he heard hidden things.
They're not even afraid of us.
For a moment, they seemed to greet each other. Corbin did not speak, but he recognized them.
Do you know them?
Ravens pass on memory. Corbin may share that kind of retention, a memory that does not forget. They reached a familiar cliff path, a place of quiet testing. Corbin mapped possibilities where others see only rocks. Corbin navigates life like a maze, observant, practical, quietly brilliant. His intelligence is different, not less, and friendship helps both learn new ways.
The revelation bridged Toby's science and Corbin's intuition. Corbin's observations of raven gatherings matched Toby's thermal data. Ravens mapped the weak ice. Their discovery was a synthesis, logic, and instinct, data, and pattern, finally united. The project transformed into a quest to understand nature's hidden languages. They saw the world anew, realizing true understanding required both analysis and wisdom. The storm had led them not to an end, but a new beginning, one where every voice in nature mattered. Together, they were ready to unlock the secrets the lake, the ice, and the ravens still held. At the bar, the bartender introduced himself, Johan Nyton. The name unlocked a memory for Corbin. Nyton was a legendary researcher who vanished while studying ravens and ice. Corbin realized the raven symbols, the saloon's location, and Nyton's presence were all connected. He recalled Nyton's journals, filled with notes on ravens as harbingers of environmental change. Corbin compared his own sketches to the raven mosaic on the floor. The patterns matched. The man before them was the missing link in their research. The black raven was Nyton's sanctuary, and their arrival was no accident. The puzzle of ravens, ice, and instinct was coming together. Through the storm, they reached a forested shoreline and found an improbable beacon, a saloon called the Black Raven.
But why the name Black Raven? In Europe, ravens are often viewed with suspicion, even negativity. For the indigenous peoples of North America, however, the raven is quite different, a symbol of creativity, change, light, and wisdom, believed to possess deep knowledge and even the ability to foresee the future.
Inside, warmth and mystery awaited, the air thick with unspoken stories. Corbin's sharp eye noticed raven motifs everywhere, a symbol, not just decoration. The saloon felt connected to something deeper, a pattern waiting to be understood. The bartender, imposing and watchful, seemed to know more than he let on. Corbin cataloged every detail, sensing the place was no accident. The Black Raven was more than shelter, it was a clue. Heeding Corbin's warning, they ventured onto the ice for one last survey. A sudden storm erased the world, leaving them lost in a whiteout. Toby's instruments failed. Panic set in. Corbin, calm, listened to the ice and wind, sensing a shoreline by the way the sound changed. He urged Toby to trust his instincts, guiding them towards safety. Toby, surrendering control, followed Corbin's lead. Through the blizzard, Corbin's intuition became their compass. Together, they began a slow trek into the unknown, trusting in a different kind of knowledge. Their challenge: predict the spring ice melt on Lake Atikamekw. Toby brought models, sensors, and data, forecasting the ice's fate with analytical precision. Corbin walked the ice, reading wildlife behavior and subtle environmental cues invisible to machines. Each evening, they compared notes. Toby's charts met Corbin's sketches, each revealing what the other missed. When Toby's models predicted the ice would hold, Corbin noticed the early return of loons, a sign of imminent thaw. Corbin's instinct cast doubt on the data, revealing a gap in the models. Their partnership became a dance of logic and intuition, each sharpening the other. Years passed, and their paths diverged, Toby into academia, Corbin into the wild. Toby mastered climate science in universities, but felt a disconnect from the world his data described. Corbin became a wilderness guide and researcher, learning climate's changes through first-hand experience. Despite distance, they exchanged ideas. Toby's research papers met Corbin's field sketches and observations. Their collaboration deepened, each providing what the other lacked. When a major research project needed both theory and ground truth, Toby called Corbin. The project would unite them again, blending science and instinct. Together, they would tackle the mystery of melting lake ice. Toby and Corbin were two halves of a whole, yet their minds worked in beautifully contrasting ways. Toby thrived in libraries, dissecting problems with logic and equations, a prodigy in academia. Corbin learned from the wild, reading the land and its creatures with patient observation and intuition. Their friendship was built on fascination with each other's perspectives. Logic meeting instinct, analysis meeting immersion. Together, they explored the world with different maps, each essential to truly knowing the land.
Are these seats taken?
Are you Johan Nyton?
That's what I'm sometimes called. But a name is just a name. This is a simplification, but the idea is the mammalian module handles deep understanding and memory. The bird module handles fast, precise patterns and sensory accuracy, and finally, both combine in decision-making. Biologically, in mammals, higher-order thinking happens in the neocortex. In birds, similar higher functions happen in the dorsal pallium. The first neural network architectures were primarily based on mammalian model logic. The addition of a parallel bird pathway happened later, when it was noticed that certain parallel and modular structures improved properties like memory, prediction, and flexible decision-making. Researchers noticed the analogy to the dorsal pallium. The bird brain's pallium and the parallel pathway in the network perform the same type of information processing. If human-like robots are built in the future, their AI brains would incorporate hybrid thinking. The deep analysis of the mammalian neocortex would enable long-term planning, understanding complex cause-effect relationships, and abstract thought. The bird's modular parallel processing would enable rapid response to a changing environment, spatial reasoning, and flexible predictions. So, the mammalian-like layered structure gives the AI systematics and depth. The bird-like network structure gives it the ability to connect distant things quickly. And since the AI's brains aren't limited by biology, they could theoretically expand into a third model, alien brains, that don't fully resemble either. Thus, the future hybrid brains could be much more human-like in the sense that they can simultaneously learn deeply and react flexibly, much like humans have both reason and intuition available at the same time.
Mechanical raven caw.
What are they saying?
It seems to me they aren't ravens, but hybrids. The raven bot revolution is already beginning.
Then I don't want to get on the wrong track. There's only one train that'll take me home.